Today's topic from my side is agentic AI in engineering, and that it's now time to act. And I would like to start with a short motivation. So what is the current state of AI in engineering, and what has been introduced in recent months and years? So I think the initial situation each company that is producing mechatronic products is facing is quite similar. We are facing very fragmented data and tool landscape. Of course, systems engineering is very knowledge intensive. It's also increasingly complex because we now integrate more and more complex E/E architectures, and also the proportion of embedded software grows. And what we, I think, all can see is that the tool landscapes and also data formats we are dealing with on a daily basis are quite proprietary. On the other hand, there are also AI capabilities from AI research coming up in recent years and especially months that can directly tackle the problems on the left side. Like, for example, when you're having a fragmented tool landscape, you can now have agentic orchestration applied in your engineering ecosystem, and you can orchestrate different tasks across different agents within different tools. Also, context management tackles the problem of knowledge intensity, because now you are able, with establishing RAG databases, knowledge graphs, and also skill MD files, you can always provide the right context to the corresponding agents, and then can automate much more complex tasks. Then I think you're all familiar with how modern LLMs work. The reasoning capability came up like one and a half years ago. And this reasoning capability provides us the capability of dealing with very complex tasks. So agents now can decompose very complex tasks into several subtasks and then execute the corresponding actions. And what is also very important is tool interoperability. So now when tools provide the corresponding APIs or MCP server, agents are now able to really operate within tools and execute engineering activities. Then let's take a look of all the use cases we can apply in engineering. And I think here the possibilities are quite limitless. Here you can see which use cases might be applicable in all the domains of the V model, starting on top left with requirement management, product architecture, and then going on with product design and simulation. And I think every big company, has such a slide in PowerPoint, but the real implementation currently is lacking a little behind. So what we want to do within AI², so our association we are funding, is we really want to show implementation. And this is why we come together in the association and all the online events, or maybe also events in person. We would like to demonstrate use cases that are applicable in real environments. And maybe you followed my posts in recent weeks, and there you can see how agents in different domains, in different tools, already execute different engineering tasks. Like, for example, in Codebeamer, you can create requirement models. In System Composer from MathWorks, you can create MBSE models, and then also along MCAD, ECAD, embedded software, there are multiple tools and multiple use cases that can already be implemented in real world. That in the next slide, I would like to introduce the concepts of vertical and horizontal system integration. And this concept was developed by Professor Eigner, who's also part and a member of our advisory board. And he subdivides the system integration into vertical and horizontal parts. So here you can see on this slide how product development is or can be presented in terms of artifacts. And whenever we are dealing only within one domain, like for example in the requirement management domain, and we are now generating from unstructured requirements, customer requirement specification or requirement models. This is a case for this use case that is pretty vertically integrated. On the other hand, and what accelerates the product development process much more is when we are able to transform artifacts from the left to the right. So whenever we can have unstructured requirements and transform it in a system architecture, or maybe also sketches or cut parts within our MCAT tool. And here we have to differentiate between vertical and horizontal integration. And when we now apply that to AI use cases, this is what we can see on this slide. We can also subdivide into vertical integrated AI use cases and horizontally integrated AI use cases. And here on this slide, you can see some research results we were publishing together with three members of our founding team. So this is based on a white paper that Accenture has published in collaboration with Fraunhofer and DFKI, so the German Research Association for AI. And here we have investigated all the use cases that were published in the engineering literature. So each dot here in this plot represents one publication. And then on the y-axis, you see how much vertically this use case is integrated, and on the x-axis, how horizontally integrated it is. And as you can see, most of the dots have a higher vertically maturity than a horizontal maturity. And I think this shows us that we are currently caught in isolation. So whenever we develop use cases in companies, we go into isolated teams. There's the requirement management team, there's the MCAT team, there's the embedded software team, and they are coming up with use cases which accelerate their daily business, their daily work. But this only leads to a very incremental acceleration of the product development. And what we would like to reach also here in this association is that we first prepare data, prepare processes, prepare tools so that we can apply AI along the whole product development process, so that we ensure here horizontal integration. And this is what we are standing for.